Next, filter characteristics of linear systems. Filter characteristics of linear systems. Filter characteristics of linear systems. As we already know that y of omega is equals to x of omega multiplied with the h of omega, or h of omega multiplied with x of omega. So, both are same, and if you carefully observe, the spectral density function of x of omega, the spectral density function of x of omega is modified by the h of omega. So, that means in some way this transfer function is changing the spectral density function of x of omega. So, that means let us consider, and that system is acting like a filter, something like a filter. That means h of omega, based upon the h of omega, you are going to get your output y of omega. Okay. Suppose if h of omega is equals to 0 for some frequencies, you are not going to get the output for that frequencies. Even though if you have the input, if h of omega is equals to 0 for some frequencies will not be available at the output. Okay. That purely depends upon the h of omega. Some frequency components may be boosted in strength and some frequency components may be attenuated, may be weakened. That means that entirely depends upon the h of omega. Okay. So, based on that, we will be having various kinds of filters. Let us consider that filters: low pass filter, high pass filter, band pass filter, band reject filter, and an all pass filter. So, all these are all important filters. What all these filters will do? The low pass filter, what this low pass filter do? That it allows, low pass filter allows low frequency components, and rejects high frequency components, Okay. This is something a filter. Let us consider the practical low pass filter, how the practical low pass filter will be. So, this is a practical low pass filter. Okay. If you give high frequencies here, so high frequencies will be attenuated. Only the low frequencies are available at the output. Okay, all the high frequencies will be filtered out by this capacitor. Okay, this is a practical characteristics. And if you carefully observe the h of omega of the above system, this is a system, interconnection of some components, and if you carefully observe the filter h of omega, modulus of h of omega for this frequency, for this system, is the frequency response would be like this. Okay. So, what I mean to say is, all the low frequencies up to this point, all the low frequencies, this is the 3 dB frequency, 3 dB point, and all the frequencies up to 3 dB point will be passed easily, and all the frequencies above this 3 dB point will be attenuated, all this. attenuated. All that means this x of omega, that x of omega is in some way is affected by this h of omega. So why? Because y of omega is equals to x of omega into h of omega. This is something multiplied. X of omega's frequency response, x of omega is multiplied with this frequency response. Okay, frequency domain representation of x of omega, the frequencies x of omega will be multiplied with this frequency response. Okay, so this is all about the low pass filter. And coming to the high pass filter, what this high pass filter? High pass filter. High pass filter means, the name itself tells, it allows high frequency components. It allows high frequency components and rejects low frequency components. That is a high pass filter. And coming to the band pass filter, this is band pass filter. Only a band of frequencies it allows and rejects all other frequencies. Okay, band of frequencies allows band of frequencies, Next, band reject filter. I'll show all these filters frequency response. Band reject filter means only a band of frequencies will get rejected and all other frequencies will be allowed. Okay, coming to the all pass filter, all the frequencies will be allowed freely. And then what is the need for the all pass filter means all the frequencies will be easily allowed. So if you want to change in the phase, okay, if you want to introduce a change in the phase, at that times we use all pass filter. Okay, all pass filter is not for the changing the magnitude of frequencies, and this is for changing the phase of a phase component of all the frequencies. That is all about the all pass filter. But anyhow, you must remember that the y of omega, that is the output of the system, would be affected by this h of omega, that is the frequency response of the system. Based on the frequency response, the input spectral density function will definitely affected by this frequency response. Okay, and we will see all the frequency responses of various kinds of filters in a moment.